continue with stoichiometry? You continue with stoichiometry, or do we need to do some new topic? Hello?
Yeah, teacher, just 1 second.
Yeah,
I'm just opening the textbook. Take the
fine,
topics.
fine. Please leave it. One number of.
Teacher, actually, at the end of this week, I'm having a test in Akash, AIDS. It's basically the first 2 chapters of chemistry. So,
Okay,
so
okay.
could
You
we
are
just
doing
focus that topic?
AIDS.
Yeah, teacher.
Yeah. Okay. First 2 chapters. Okay, the first 2 chapters consist of this only now, the mole concept and atomic structure.
Yeah, yeah.
Okay.
That.
So is mole concept clear to you, or you
Yeah,
want
teacher,
to
it is clear now. It is clear.
limiting reagent? Limiting reagent is also clear.
Yes, teacher.
Okay, fine. Then I will switch on to the next topic, that is the atomic structure, right?
Okay.
Okay, or any other thing you tell me. Be ready
No,
with
teacher, we
what
can
you
start.
want to study. Okay, fine. See, basically what we will see in this chapter accounts for the electronic configuration, how the new combination takes place, and how stability is achieved, and how exactly the electrons are placed in this. Okay, now here is the first most important thing that was proposed during that time, was the Dalton's atomic theory. Now, what is Dalton's atomic theory? Dalton's atomic theory, it postulated first that atom is the smallest, dense, you can say, and hard indivisible particle. Okay, it is the smallest, dense, and hard indivisible particle, and each element, it consists of a specific type of atoms. Then the properties of elements differ. Why? Why silver, gold, copper, iron, or you can say gases, they have different properties because they contain
Excuse me,
yes,
excuse me, just a minute, ma'am. Neil, kindly take notes, okay?
Yeah, teacher, I'm taking notes right now.
Okay, sorry to interrupt. Oh.
They contain different kinds of atoms. Okay, contained in them. So, therefore, this theory was very much satisfactory. Why? This theory was satisfactory as it provided basis for law of chemical combination. What? Law of chemical combination. It means that all the elements, they chemically combine to give us a stable product. Got it?
Yes. Yes.
Now among these, one of these, there will be a MCQ question. See, here you are majorly focusing on MCQs. So you can get any one of these options, and this is very important, law of chemical combination. So on what theory it is based? It is based on the theory of law of chemical combinations. Okay. Now there are, have you written? Should I rub?
Yeah, I've written.
Okay. So, what are the limitations? Can you tell me what are the limitations of this Dalton's theory? See, first limitation was that it could not explain. It could not explain why atoms of different kinds, they differ in valency and mass. Why the valency of carbon is 4, why the valency of oxygen is -2, why the valency of oxygen is -1. So, whatever we are saying, we need to explain all this properly, right? So, for the proper explanation, it was very important for us to understand the difference, because in the case of chemistry or science, everything should be proved. But Dalton's theory could not prove this. And next is written.
Yes, teacher.
And next is the presence of, or you can say the discovery of isobars and isotopes. What they showed? They showed that atoms of different or you can say atoms of different elements have different atomic masses.
This will be a separate topic, right? Not in the limitations.
No, it is under limitations only.
Okay.
Okay, so wait. I'll tell you in a better way. So this is what is the second limitation? The second limitation is discovery of, write down this way.
Okay.
Discovery of isotopes and isobars. Now, can you tell me what are isotopes?
Isotopes are basically the atoms with a similar element but different atomic numbers, mass.
Atoms, no, atoms
C12 and
of
C14.
yeah, very good. Atoms of same elements have different atomic masses. Okay. When they have different atomic masses, they are called as isotopes. And another one is isobars. What is isobar saying? Atoms of
Atoms, different atomic numbers but same mass number.
kind. Yes. Atoms of different kinds may have same atomic masses. This is isobars. So it needed to be clear on this only, but he could not clear about the isotopes and isobars. Got it? So this is among one of the options, yeah. And third is the discovery of various subatomic particles. like protons, electrons, X-rays, etc. So finally, during the late 19th century, the idea was developed that atom was divisible into protons, electrons, and got it. So when he
Got it.
was understanding all this, at that time it was not at all proved. It was proved very late. Okay, so these were all the limitations of the Dalton's theory.
Atomic theory.
Okay. Yeah. Okay. Now we'll start with fundamental particles. Fundamental particles means first is about the electron. See, basically in electron, it was Sir J.J. Thomson, who in 1897, he discovered that electrons are negatively charged particles. Okay. So how he studied? He studied by using a cathode ray tube. Okay. So what they did, they took a sealed cathode tube. It was sealed on both the ends. It was having a metal strip. And one part was called as negative and another part was positive. Negative, and this was positive. You know, it is not that directly they told that it is negative. They studied. They, with the help of this reaction, they studied whether rays were emitted from one part or this part. But when they chose this part, this is called as cathode. Okay. And the right one is called as anode. And when this anode and cathode, it was connected, and one major thing what they did was, from the lower point, they took out all the air. So it is a vacuum channel. Through this, the entire tube was evacuated. Means there was no air which was present. Okay. So when air was absent and when this was connected to the wire, what they saw, that this is cathode ray discharge tube. Cathode ray discharge tube, CRDT we call it as. So this discharge tube is how much? This discharge tube is 60 centimeters long. And at both these ends, they have a thin strip of metal. And these metals, they are known as what? They are known as electrodes. Okay. And so therefore we named this tube. This tube was called as Crookes tube. Now this is your neat question. Okay. This cathode ray discharge tube is known as Crookes tube, and the negative part is cathode and positive part is anode. Now, when a gas enclosed at a low pressure, you know, the pressure which was maintained here is 10 raised to minus 4 atmosphere. When such a low pressure was maintained and it was subjected to a high voltage, How much amount of voltage? Voltage means minus 10,000 volt. When this much, when nearly equal to 10,000 volt, when this was applied, invisible rays, they start originating from the cathode. Okay. And here towards this anode, it started producing light greenish color rays. See, it depended upon the gas which was used. Okay. Are you understanding that this is a
Yes, ma'am.
cathode ray discharge tube? Cathode is present, anode is present. Two metal plates are placed on both the ends, connected with the battery, and a pressure of 10 raised to minus 4 atmosphere is maintained with the voltage of nearly equal to 10,000 volt. So a blue light, it emitted from the cathode, or you can say invisible rays. I've made it blue because so
Okay.
that you can at least relate to it. Yeah. So
Okay. Okay.
invisible rays, it originated from the cathode, but the greenish glow, it was made, it was produced behind the anode. And this anode was actually perforated. It was having a hole. It means that this ray traveled in a straight line and passed through this perforation. But on the back side, it produced a green color. And
I'm
this
making.
greenish glow, yeah, this greenish glow was present.
Yes.
I'm making again you draw, understand it. So we can say that invisible rays, it started originating. Here was anode, and this anode had a perforation. Okay. And on the back side, you can see there was a coating. Actually, on the back side of anode was a coating. And this coating was of zinc sulfide, phosphorescent material. Okay, like you have an X-ray. X-ray is black. You can see the X-ray now, the spottings of the bone structure, entire, everything you can see on the X-ray. So you can understand that exactly that same material was kept behind. On that material, greenish color glow was obtained. So these rays, which showed greenish color tinge on the phosphorescent material, they were known as cathode rays. Okay, so cathode rays, they travel in a straight line. How do we know they travel in a straight line? Because these rays started here and then they passed through this perforation. And the area from which they passed, exactly at that point on the zinc sulfide screen, the glow could be found. Are you getting?
Yes, teacher.
So it says that light travels in a straight line. Similarly, cathode rays, they travel in a straight line. Okay. Now, second thing was that this cathode rays consist of what? Cathode rays, they consist of negatively charged particles, and these negatively charged particles, they are called as electrons. Next, these cathode rays, they produce mechanical effect. Now, what is this mechanical effect? Mechanical effect means when a wheel was placed on their path, so they can rotate the wheel. that placed in their path. Okay, so what does it mean? It means that these rays have the ability to rotate also. But what is the primary requisite? The primary requisite is that it should be in vacuum. Okay, if vacuum is created, then only we can find out all these possibilities. Then next is the cathode rays travel with high speed. Okay.
Okay.
Next is cathode rays can cause fluorescence. Am I a bit fast or is it okay? Or you want to be a bit slow?
No, teacher. No, teacher, it's okay. I just wanted to know what was the first point because I started writing from the second point. I didn't get the first point.
Which part? This one? No, the first part was that only, no? The first part was
The
actually
diagram, na?
cathode. Yeah, cathode rays
Rays
travel
from
in straight line.
rays from cathode to anode called cathode rays. That was the first point, right?
Yeah, yes.
Okay, okay. Then okay. Then okay.
Or you can write down first point, that is cathode rays always travel in a straight line. I explained you the entire structure, na? In that,
Yes,
the
sir.
property, the first property was that, and after these, the second properties.
Oh,
Right, huh?
yeah.
Okay. Now, till this point, can you give me a recap of whatever you have understood till now so that, at least I get to know that it is clear, everything is clear to you?
Teacher, could you show the fifth point once more? After cathode rays travel with high speed.
Yeah.
Yeah, teacher. Should I tell now?
Yeah, please.
So first you had explained about Dalton's atomic theory, how the atom is the smallest, dense and hard, indivisible particle. It consists of specific types of atoms and each element has different kinds of atoms contained in them. It provided the basis for law of chemical combination. Its limitations were that it could not explain why atoms of different kinds differ in a valency and mass. Then after that, second limitation was discovery of isotopes and isobars, which definitions you explained. And the third limitation was the discovery of various subatomic particles like protons, electrons, neutrons, and X-rays. Then uske baad you started discovery of electron. By Sir J.J. Thomson had discovered the electrons, and electrons are negatively charged particles. Then you drew the diagram of the cathode ray tube, which showed the cathode, anode. Its length was 60 centimeters. There was a vacuum in the middle, and at both the ends, electrodes were present. This is also called Crookes tube diagram. Then you explained that the volts need to be 10,000 volts. Pressure needs to be 10 raised to minus 4 atm. The invisible rays originate from the cathode and reach the anode, and they started producing light green color at light green glow at anode. The anode is perforated and has a coating of zinc ZNS. Rays, rays from the cathode to the anode are called cathode rays. Then you explained five properties of cathode rays, which is they travel in a straight line. They contain negatively charged particles called electrons. They have mechanical effect. They travel with high speed and can cause fluorescence.
Good. Now, Another very, see, all these points are what? They are options for your NEET question. The most important that I have given you. Now, apart from that, the next point is cathode rays. Cathode rays heat the object on which they fall. Okay, they heat the object on which they fall. Now, why? Why heating takes place? Can you tell me why heating takes place? Yes?
No, not sir. I mean, if you put pressure on any object, it will produce heat due to the
No,
friction.
no, 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 no. We have to be logic. See, basically, it fall due to transfer of kinetic energy. Due to transfer of kinetic energy to the object. So now very important. When cathode rays, they fall on heavy objects, what do they do? Or you can say when cathode ray falls on heavy metals. What are heavy metals? Like lead. What do they do? X-rays are produced. Now this is another very, very important NEET question. Mind it. This one. 5-star NEET question. This is also NEET question. You will get this as option. Okay.
Okay.
So what do we see that cathode rays, they have most important property, that is the ionizing. Cathode ray, they have ionizing power. So what do? They ionize the gas. Okay, therefore, when vacuum was created, what we saw? That some gas was added inside it. Vacuum was created, gas was placed, and that gas showed green color on the anode when the cathode ray was passed. So why we see different color? We see different color because the gas ionizes. Got it?
One second. One second.
Fine, fine.
Here it is.
So what we see is that next, cathode rays, it produces scintillation. It produces scintillation where? On the photographic plate. Scintillation means what? Right? We saw on the back side of anode, what you saw? You saw a green glow.
Yes.
It was created on the photographic plate. How will you resemble the, you know, have you ever seen the negatives of a photograph?
No, not sir.
Not seen, no, because you people are born in total high-tech world. So now, no photographs. But when you get your passport done, a passport photograph done, right? Whenever you go and ask uncle, give me the negatives, please. So you can see negative will have an outline of your this, and it will be totally like an X-ray film. Have you seen an X-ray?
Yes.
Ah, exactly. That X-ray has the, the entire image of the bone, where it is cracked, where it is continuous, what problems, all these things you can see. Exactly, that is the photographic plate. So that photographic plate will show the scintillating effect. And finally, the last one, they can penetrate through thin metallic sheets. Okay.
Okay.
Now I'm giving you one question that this is a AIPMT question, that cathode rays have,
Okay.
this is neat question. First, mass only. Second, charge only. Third is no mass, no charge. No mass and charge. And last is mass and charge both. Bolo.
Teacher, it will be mass and charge both, because because it is able to move the pinwheel that is placed in the middle of the cathode ray tube, and charge because it is consisting of negatively charged particles called electrons.
Yes. Very good. Now, next is, we will directly see the charge by mass ratio. See, when these cathode rays, they were passed through the magnetic and electric field, what we saw, that it can easily be swing. You can easily move it. Momentum can be seen. Okay. So with the help of these variations, the charge by mass ratio was found. And this charge by mass ratio of an electron is given by E by M. That is 1.758820 into 10 raised to 11 coulombs per kg. Remember this. You have to learn. See, there are a lot of things that you have to learn. Where M is what? M is the mass of electron in kg. Okay. And E is what? E is the magnitude of charge of electrons in coulomb.
Of.
Okay. So
Okay.
next we'll start with proton. So this is totally clear.
Yeah, teacher, I just had one doubt. Could you go back to that slide? What is written? It is coulombs per kilogram, right?
Yeah, coulombs per
Yes.
kg.
Couldn't make out what was written. That's
Okay. Coulombs per kg. If I take a thinner one, let me check if I can handle it. Done?
yeah, done, teacher.
Chalo. Next is now proton. See, basically, proton was discovered by Goldstein. And it is positively charged particle. Proton is what? Proton is positively charged particle. Now this canal ray experiment, okay, that is the anode ray experiment. See, like how we discovered the cathode ray, similarly an experiment for the anode ray was performed. And this anode ray experiment is also known as canal ray experiment. Okay, so Goldstein in 1886, he performed this experiment, and this experiment led to the discovery of protons. Okay, so once when the electrons were discovered, then protons were discovered. So finally, you know, the structure of atom, the theory of structure of atom was strengthened. Why? Because in this experiment, he actually applied high voltage. He applied high voltage across a discharge tube. Okay, so when he applied high voltage across a discharge tube, now here, which had a perforated cathode. Mind it, what we studied in earlier one, the anode was perforated, but in this,
The
yeah,
cathode is
why it
perforated.
was, yeah, why it was perforated? It was perforated because we can very easily see the effect which could be passed on.
Just one
Got it?
second.
Yeah,
Just
yeah, please
writing
write.
it down.
Right, right. I'm not in a hurry. I'm just explaining. But what
Okay.
I want is whatever we study, it has to be clear so that you know you don't waste your time in understanding it again. So it has to be
Okay.
clear. Now, what we see is a faint luminous ray was seen. Extending from the holes in the back of cathode. The same thing, mind it. Anode, cathode was on the same place. It was not that the cathode was shifted on the right side. In the discharge tube, cathode will remain here and anode will remain here. Now the rays traveled from anode to cathode. Okay, and they could see the scintillating effect. Got it? So now what are the properties of cathode rays? Write down. The first property is
Teacher, teacher, teacher.
anode rays.
I wasn't done with that. I'm done with that. This last line was written there.
Hmm.
Yeah, teacher, I'm done.
Now anode rays, first property is they travel in straight line. Number two, anode rays are material particle. What? Anode rays are material particle. Anode rays are positively charged. Anode rays get swung by external magnetic field. Okay. Then anode rays affect the photographic plane. Then next is E by M ratio of anode rays is less than electrons. Now this is very, very important NEET question. Write this down.
Yeah, teacher, done.
Done? Okay.
Yeah, done.
And the last is these anode rays produces flashes of light on zinc sulfide screen. Now this zinc sulfide is a neat question. Now this zinc sulfide, you can call it as a fluorescent material, or you can say phosphorescent material. Are you getting?
Yeah, teacher, I'm getting. I wrote.
So now you just explain me about the anode rays, the properties of anode rays, the protons.
Yeah, teacher.
Please.
First of all, they travel in a straight line, and second, they have material particles. Third, they are positively charged rays, that is, they contain protons. Then fourth, they get swinged by the external magnetic fields. Fifth, they affect the photographic plate. Sixth, which is
Yes.
the E by M ratio of anode rays is less than electrons. Teacher, one more question. Instead of electrons, can we write cathode rays as well? In case अगर लिखना हो. In
Pardon?
the in the point E by M ratio of anode rays is less than electrons. Can we replace
Yeah,
electrons with cathode rays? That we must.
it is less than electrons.
Okay. Then after that, these anode rays
Can you
produce
no, no, no. Now describe me with the experiment.
as in
Explain me the experiment of anode rays.
the discovery
Right?
of protons.
Yeah, the
Almost
discovery. The way I explained you about cathode, now you explain me about anode.
okay. First of all, the discovery of protons was done by Goldstein in 1886. It was called the anode ray experiment. The anode rays are positively charged and they were proven through the canal ray experiment. He had applied high voltage across the discharge tube. The discharge tube had a perforated cathode. The
Yeah.
perforated cathode was used in order allow passage of protons and let them be detected on the anode in the anode during the
It was
reaction.
perforated. It was perforated and evacuated.
Evacuate.
Vacuum.
Okay.
Yeah, that is most important. See, I want you to explain me that part. It was totally vacuumized.
Yes, because it had a vacuum. No air was present in the tube.
Yeah.
Okay. Then during the experiment, a faint luminous glow with a ray was seen extending from the holes in the back of the cathode. Uh, the
Yes.
anode rays produced flashes of light on zinc sulfide screen.
Yeah. Right. Fine.
Yeah, teacher,
Now,
that's
fine. Now, I want to ask you one question. What were the important conditions? Write down this question.
okay.
What were the important conditions maintained in the discharge tube? Yes. Yes.
Yeah, teacher, just 1 second.
Hmm.
First one was high voltage, as mentioned in the fourth point, and
Yeah.
second was low pressure because they needed fewer gas molecules in the tube, which allowed the electrons, the protons, to move towards the anode to collide with the gas molecule. No, low pressure, low pressure.
Okay. See, is cathode ray dependent upon the nature of gas?
Is
Another neat question. Cathode ray depends upon nature of gas? No.
no.
But anode rays, you can say E by M value is dependent upon the nature of the gas. It is maximum. Now this is your neat question. It is maximum when hydrogen gas is present. Okay. When hydrogen gas is present, at that time only it is maximum. Got it? The difference now,
Got it.
these questions will be put to you. Now finally we'll talk about neutrons. Should I rub?
No, teacher, one second. Right.
Okay.
Okay, yeah, teacher.
Hmm. Now next is neutrons. Write down. So in 1932, Chadwick, what he did? He bombarded beryllium with a stream of alpha particles. So beryllium was bombarded with a stream of alpha particles, that is He plus 2. He noticed that penetrating a radiation penetrating radiations were produced. But what you know? These radiations which did not affected or you can write down which were not affected by magnetic and electric field. Means when these rays, when beryllium was bombarded with alpha particles. Okay, helium is alpha particle. Alpha means positively charged particles. When it was bombarded, then there was no effect on these radiations. No effect of both electric and magnetic field. These radiations, since they were not having any effect of both electric and magnetic field, these radiations were considered as neutral particles. Got it? Why they were considered as neutral particles? Because they were unaffected by electric and magnetic field. Got it? Hello?
Yeah, teacher, got it.
Huh.
Finished writing that.
So, yeah. So these radiations consisted of neutral particles, which were called neutrons. Okay, so how will you write? You will write bombardment with beryllium, na? Beryllium 9, 4. When bombarded by helium, you got carbon 6 plus neutron was emitted. Similarly, barium 11 plus helium 4, 2. It gave nitrogen 14 plus okay. So what we saw that neutrons were unaffected by both electric and magnetic fields. Now this reaction, this is very important. So now you should understand the theory. After understanding the theory, only you can present with the assertions and reasons. Now, whatever I've given you, they are in MCQ also, and they are in assertion and reason form also.
Okay.
Okay. So
Oh.
basically, we see that this the neutron is relatively massive. What? Neutron is massive but neutral. And it is scarcely affected by the electron cloud surrounding the nucleus. It has got no effect of both positive and negative barriers. So since it does not have, therefore it can penetrate the nucleus of any element. Therefore, we say that the mass of element comprises of both protons and neutrons. And another most important exceptional question is, you can write down,
Okay.
that neutron is fundamental particle. Of all atomic nucleus. In all the atomic nucleus, you will see the presence of neutron, except hydrogen. Hydrogen does not have a nucleus. Okay.
Okay.
So with this, we have totally finished up the fundamental particles, the in-depth analysis, along with the neat questions and assertion reason questions. Okay. In the next class, we'll be studying about the models of atom, but I want you to go through the NCERT also. Because you go through NCERT, that is very important. You have to do the related questions, and there's a table which is given. You learn that table, the E by M ratio, the positive, the negative, everything you have to learn. Okay?
Yes.
Chalo. Bye then.
Right, sir.
Bye.